So note, okay, let me talk about what I did in preparation for today's session, because the basic idea is, I've got a fair amount of sample code now in all these demos that I've been writing, and there have been certain very ugly things that I've been leaning on. For example, I'm using Printf the whole time, and Printf is really one of the worst functions in C and also one of the ones that you need to call the most. So I realized that now is sort of a good time to replace that. During the last stream, we started adding new stuff like the question mark operator, and that's still not really done. So I wanted to just come in and harden some other things before I go on and add more new stuff. So actually, between last stream and now, I got C compilation working again. If you've been astute in paying attention during all these last few demos, you'll note that I was always running from within the compiler. Whereas this time, now I compiled this to C, and now I'm running the C compiler on the output C program to generate machine code executable, as I did in the first few demos for this language. But between then and now, all that got disabled and rewritten. I can show you what the C code sort of looks like. It's not pretty right now, and it's not as fast as it will be probably because it uses unions for a register type all over the place, but that's relatively straightforward to get rid of. I just don't want to do it yet. So at the beginning it sort of defines some things, and at the end there's some boilerplate, and here's some stuff that initializes global variables at startup, because I didn't want to like anytime you have a function pointer in global scope or something. And actually most of these are constants that aren't actually referred to, so they can all go away. But anyway, the actual functions look like this. So they look sort of like a really ugly C translation of the bytecode. Like, hey, here's a bunch of registers. These don't correspond to machine registers. These are almost like SSA values, except a few of them get reused a few times. And this is kind of a long function, so it has a lot of them. And, so this is sort of the level of code that we're generating. It is not very high level. It looks maybe not that much unlike machine code. But actually, if you have a crash, you can actually debug this in Visual Studio, and you can print out the values of the registers and all that. So that is very handy. It's better than nothing, that's for sure. Anyway, so then what I did in preparation for today, I decided I wanted to replace things that depend on the C standard library, because I want to get serious about printing things and using files and allocating things and using allocators, because those should guide the higher level features. I don't want to end up in a spot where I finish polymorphism and do all this other stuff, and then it's like hard to use allocators and things. So Printf seemed like a good place to start, because one of the big problems with Printf in C is it's not type safe, and you can crash your program just by calling it wrong. And we showed some ways to deal with that before. Like I said, hey, you can use this check function, for example, in one of those first couple demos. But it's nicer if you just don't have that problem at all. And we have mechanisms by which we can avoid that problem, like we have now type-safe variable argument functions, where you pass a bunch of arguments and they get placed automatically by the compiler into type any structs that you can then query, right? And we have runtime type information that'll tell you as much as you want to know about that stuff. And so I figure it's time to use that to rewrite a print function from the ground up, and then I can replace it in all the old code, and then any new code that I write can use that new print function. So that's the plan. Now, in preparation for that, I wanted a way to output strings to the console that doesn't go through C's printf, and that's going to be OS dependent. As you'll notice here, when I ran the compiler, it printed hello sailor, and the reason it did that was because, I've got too many editors open. Let me close this one. And let me close this one. All right, one editor. So if I go into the main program of the compiler, I was just doing a test where I was learning how to use write file to write to standard out in Windows. So this is a platform specific thing that I'm doing, but you can get this handle, right? That's for standard out, or the equivalent of standard out, right? And then you can call this write file function, and it'll tell you how much it wrote and all that stuff. And this was just me using it in C to get used to it, and I can get rid of that now. Now, once I did that, in the sort of what sort of suffices for the basic module here, I've then added declarations for the relevant things to do this stuff in Windows. I don't have a way, like if I were doing this in C, I'd say if def Windows or something around this code, and it would only compile in Windows. I don't have a way to do that yet. So right now, this isn't going to work on Linux until I add some way to do platform-specific code. Actually, because I can run arbitrary things at compile time, I could do something a little convoluted where I have a separate file for this stuff and I include it, or I put it in a string and I include it. I already demoed all that. But I'd like a way to do this in a more straightforward and not convoluted way. So I'm not going to do those crazy things. And I'm just going to let it be broken in OSs besides Windows until some kind of mechanism is added. Anyway, so we have our declaration for get standard handle and write file. And we're going to be able to use those now. So that's about it. Oh, one other thing I can mention that I did was I've started to migrate things out. So up here are all these declarations for functions that I'm using basically out of the C standard library. So all these print functions you just call printf. Printf is what I've been using to print strings, right? It's foreign and it's being supplied by C. And the problem with that is there's this whole big heavyweight C runtime library that comes along with that. And we don't want to rely on that runtime library at all in the long term, right? We want to be able to run on the bare metal. So all these functions have to go eventually. We can't call C's cosine or sine or square root or scanf or any of this stuff. Some of these functions are easy to replace, like strlen is easy to replace, strdup is easy to replace. Printf is pretty hard if you're going to do all the functionality. So we're going to at least start printf and then see where it goes. I replaced so array add and array reserve that manipulate the standard array used to be in that same CPP file that all that C standard library stuff was used from, but I've migrated it out to the language here. So this is now native. So, you know, that's not too big of a deal. It's not a very complicated function. Like, hey, if you're adding stuff to a dynamic array and it needs to reallocate and like put the members in. But it's cool, you know, it uses polymorphism, you know, in an extensive way to do real things. So that's good. Note that it doesn't use a specialized allocator. It's always calling array reserve, and array reserve doesn't take an allocator argument. It just calls malloc. In the long term, that's going to have to change because you need to be able to override the allocator on a standard array if anybody is going to want to use that array, at least in the game world. Okay, so let's go back to BIF, which, if you recall, we were sort of using that for our test of this question mark operator, and we're just going to delete all this code, and we're going to have it not do anything. And we'll leave in the running in the compiler for now, just because it's more expedient than me having to run the executable all the time. Let's recompile the compiler to get rid of that hello sailor, and so what happened to my, well, test BIF. All right, so it doesn't do anything. You know, if it had done something interesting, we would have seen that here. In fact, let's just go and put a printf in it. Printf, our mission is to replace printf. All right, so let's do that again. So we see that here. So our program's running, and actually, if we run it now, we're building an executable too. But I'm not really going to use that because we get to see immediately what happens when we run it in the compiler. Okay, now I think I'm going to call my new function print, and the problem is I have an old function print in here, so I'm just going to get rid of that declaration. All right, I had this print that just prints a string, and you know what? All this stuff, print int, print float, that's all going bye-bye. We're going to use printf for a while to help us debug, right? So while we're writing our own better printf, we're going to use the old printf, but the goal is to get rid of it eventually. So let's go back to, instead of printing this, we're going to say there's some string that equals that, right? And I'm going to say output is going to be get standard handle of standard output handle, and write file output s strlen of s, and just to be a good citizen, I'm going to ask how much we got returned, and for this overlapped thing, I'm going to return null. Oh, and then status, this returns a status variable. You know, if it were our native function, it would return bool, but this is the Windows API. We don't really have the option of cleaning it up unless you want to wrap it with useless things, which I would rather not do. Note that I'm not using Windows as types like dword and all that and handle. I made the decision when I was adapting free type to just get rid of all these weird, bizarre types that everybody makes all the time. We could, something like handle you might consider to be, well, let's just make this work, and then let's just show what you would do if you want those types. So we're checking the status. That should write something out, and now we'll say printf status is, right, so that's just going to tell us, oh, characters written. So let's just make sure that works. Whoops, not that. Compile it. Didn't like it. Oh, right. Potential loss of information, trying to fit 64 bits into 32 bits. Can't do this without an explicit cast. The reason is, again, this is a Win32 API. We don't have the option of changing the sizes of the types. And the thing is, our functions are made to be easy with 64-bit programs, and Windows was made to be easy with 32-bit programs. So, you know, basically we're using a strlen here. So I'm going to use autocast, which is still XX. I may change it at some point to CT, but this is just a signal that says, like, I know this isn't right, just make it work, right? So we just made it work. So we've printed, our mission is to replace printf via this low-level write file. And the status is 1, which means it succeeded, and characters written was 34. So that's great. So now we are sort of in business. We can start doing the kinds of things that I talked about way back, or vaguely way back in the varargs demo. And we may go back to that varargs demo to grab some things. But first, let's start building a structure. It's one of the goals that we want is to be able to treat files and memory as the same, right? Because that's a big pain in C when you have to change what you're doing. So, you know, the standard I/O stuff in C uses this macro, which is super inconvenient, called capital file. And you can't really manipulate that, even though it's got buffers in it and stuff. So our goal is going to actually make a buffer that you can manipulate, and that you can, you know, read yourself and write yourself, but that printf handles. You might just use a version of printf that prints into that buffer and then get the buffer back. You might pass the buffer to a file writing thing. You might pass it to a network writing thing, and whatever. So we're just going to build an abstraction that lets you put pieces together to make that stuff happen, which is a lot more difficult or crufty in C. And also, I'm not 100% sure how I'm going to solve this yet, but I want you to be able to expand this printf kind of thing with your own ways of printing things. So if you have a data structure, we ought to be able to set up function overloading and such so that you can just printf your data structure in a regular printf along with everything else. I'm not 100% sure how I'm going to pull that off. because it's sort of like the type any that I'm using right now, or that I'm about to start using, is a runtime thing. And usually if you want to dispatch to a different function, that's a compile time thing. And I don't know how to solve that, and maybe we need to do like variadic polymorphism or something, which I guess we can do already. I didn't ever demo that, but I think it'll just work. Anyway, first things first. Let's just start programming stuff. So I'm gonna have this function called print, and it's gonna take arguments. We're not going to bother building that buffer yet. We're just going to start by just printing to the console, and then as we get more sophisticated and we're able to handle things, then we'll switch to buffered things. So I'm going to take arguments, which is varargs, and I'm going to return void. So I'm not even going to say what I return. And I'm just going to, for now, say for everything in args. Remember, these are going to be type any. And I can go look at what type any is here. Right? It's a struct that has a type and a value pointer. So what I do is I look at that type and I dispatch on the value pointer. And I did this in the which one was it? The variable arguments demo from way back. So we may go and crib some code from there. But first, let's just do something very basic. So for the number of arguments, okay, we're going to say printf print got %d arguments print or args dot count. Let's make sure all this stuff still works. Printf argument %d has type %d and it index, right? And then the type of it will be args, it dot type dot, and here's what type info looks like. It has another thing called type that's an enum. And we're just going to print that as an integer. We're being sloppy here. We just want to know that this works. So instead of this, let's continue our mission is replace printf, and then we'll just say print hi, my name is 10. All right, so let's see what that does. Okay, exactly what we wanted. So we got 5 arguments. The first 4 are the same type, that's string, and the last one is 0. So now let's say I don't have a switch statement in this language yet, so we're going to start doing ifs all over the place. I'm going to say t is it.type.type because we're going to use that a lot. So if t is equal to, let's using type info tag.members so that we can refer to all of these in our local scope without having to namespace them. So if t is equal to string, then we're going to say s is cast to string it dot value pointer, and I'm going to make a function called write string s, right? And write string is just going to call write file like this. So I'm going to say in startup, we're going to say standard output equals this. We're going to say standard output is an S32. That's a global that everybody can get at. We're going to say standard output gets this handle. And then here we're going to say write string of s and write string takes a string, returns void. We're just going to ignore that stuff. Status code for now. Maybe that'll compile. Looks kind of reasonable. Let's Let's see what happens. Oh, tie info tag, that's no good. And undeclared identified or output. That's standard output. Ooh, I really did something bad though. Okay, our mission is to replace printf worked. Oh, you know what? So it.valuePointer is a pointer to a string. So we actually we want to dereference a cast to a pointer to a string, right? All right. So here we go. Hi, my name is, and then we never did a new line. So all right. Hi, my name is new line, and then we've got an integer, right? So what do I want to do now? Let's handle integers, right? Let's let me try replacing this. So like I said, if you want to declare Windows types, you could do that. So I could say handle, right, is a type alias for S32. So the value of this identifier handle is the same as this type, right? And I could say this is a handle, and I don't really want to go redeclare get standard handle because I don't know if I want to pollute the header file, but this should work, I think. Yeah, so that works. And so I could use this type handle if I want to. I don't really want to right now because it doesn't really help anything. Okay. Because, you know, like one of the reasons why I want to strip away all these BS types that people add all the time is they usually just add complexity. Like often the intention is to simplify things, but often things are not really simplified. So I don't know. In this case, if I were doing a big Windows program, I might make a separate type for handle, but I wouldn't make all the separate types that Windows tries to force upon you because they're nuts and they just make things crazy. So, you know, my preference would be to sort of feel it out and have some cupcake. Is handle unsigned? I don't think it is. The reason I don't think it is because these definitions of standard output handle and stuff like that are negative according to Windows. So it's got to be signed, right? Unless this is something else that's not a handle. No, because it gets a handle argument. It has to be signed, guys. Okay. Anyway, someone's saying it's a void pointer, which is especially bizarre. Let me pass in a negative integer as a void pointer. Thanks, Windows API. So let's get back to business here. So now that we know that multiple arguments work, I'm just going to do this. Hello, my name is, right, and then let's say 42, and then new line. So we want to start making print things like this work, where we can put all sorts of different types in here, but then eventually we'll want to be able to format them in different ways. And I'll show in a bit how we can do that. But first, let's get integers printing. And I'm going to do them in a different way than last time. Okay, so first, let's say if t is integer, Then we're going to say value, well, what we want to do here. It's a little bit annoying. This is one of those cases where if this were like a polymorphic thing, then we could do whatever we want here. This is not a polymorphic thing. This is, we're going to have to do a little bit of work because we don't know, we want to handle all sizes of integer. And we don't know what size this is. So let's make a helper function that handles all sizes of integer for signed or unsigned and returns us the result. So we're going to say if, well, let's get the integer info. So type info integer. I'm going to say what do I'm going to call this, I don't know, info integer. It's kind of a long name. Cast pointer to type info integer it, right? So it.type, right? It is which argument we're visiting, and it.type is the type info struct. Since we know it's an integer, we cast it to a type info integer, right? And so now we can ask, is it signed, and what's the size in bits, right? So here's what we're going to do. We're going to promote it to a 64-bit integer of whatever type it is. And then we're going to call a print routine that handles 64-bit integers. And that way we'll be able to handle all the different sizes and just sort of can compress them into one code path instead of making a bunch of code paths. So we'll say if, let's just call it info, whatever, it's local. If, I keep putting open parens in front of my ifs, which I don't need to do in this language. If info dot signed, then we'll do one thing, else, then we'll do another thing. And the thing that we'll do here is, we'll say, let's just say v is going to be the value, right? And that's an S64. And what the hell, we'll uninitialize it because we know we're going to initialize it. So v is going to be equal to get S64 from any it what do I need to pass it? It dot, well, I know the type, okay, from void pointer, right? It dot value pointer and info. So we're going to pass the type info. Well, we know that it's signed. We just need the size in bits. So info dot size in bits and the value pointer, right? And if it's not signed, then we'll get a U60. Oh. Yeah, okay. We need to be a little bit more. So we're going to make different. Ooh, okay. This is where we need to think ahead a little bit. V is going to be a U64. We're going to make an integer printing routine that prints out U64s no matter what. If we get a signed number, we're going to check if it's less than 0. If so, we're going to print out a leading minus, and then we're going to call the U64 stuff, right? Yeah, that seems plausible to me. So we're going to say v signed is get S64. If v signed is less than 0, then write string minus And we may have to, when we start doing formatting options, we may not just be able to write the minus, because if we're putting not leading zeros and we want to indent it or something, then that's, we might need the minus to move. But for now, we're going to write the minus, and then, well, we're going to say v is cast to u64 of minus v signed, right? Otherwise, v is cast of u64 of v signed with no minus, right? So otherwise, that, and then, wow, we've got a few functions to write at this point. And then we'll say, instead of actually printing the integer in yet, we're just going to punt here for a second and say, punting, we got v equals %d, right? LLD, because it's an S64, or U64. Okay, so once again, we've got a U64. It's uninitialized. If the number that we got passed in was signed, we promote it to S64. We write a minus sign if it's negative. We make it into a U64, right? And then, or if it wasn't signed, we just get a U64 straight away. And then we go. All right. So let's write this function. Get S64 from void pointer. Takes a pointer. And size in bits was a U32 because that's how it's packed into the info struct, and I'm just going to leave it that way, right? That's really bigger than you need, but it's fine. I mean, when it's a function argument, it doesn't make much sense to make it small. Really, for convenience, I would make this maybe 64 bits, but it's not worth it right now. Okay, so I'm going to say, like I said, I don't have a switch statement. Eventually, this would all be switch statements. But for now, I will say, if size in bits is equal to 64, return star cast this is signed return we're casting to an S64. Oh no, everything should up promote to S64, right? Okay, this should be fine. So we're going to cast to a pointer to S64 pointer, right? And return that. And then if we're 32, if we're 16, if we're 8, and if we get down here, we should assert false. Assert doesn't actually panic the program right now, but it'll print assert failed. So that seems fine, right? Oh, I need to say that this returns S64. Let's try it. Oh, we need to write the U64 version before we'll compile. So S6, or let's try replacing S with U. No, no, yes, no, no. Okay, that's pointless. Let's just do it. Okay. That's really, we could factor this into something polymorphic if we want, but that's not that good of an idea. It's not really, I'd rather, for this little complexity, I would rather just paste it. Okay, so we've got S64 from void pointer. We've got get U64 from void pointer. And the reason you want these to be different is, when you cast up from, for example, 8 bits to 64 bits, if it's signed and this is negative, you want to sign extend, right? And if it's unsigned and you don't want to sign extend if it's the leading bit is set to 1, right? That's why this is different code and why it's not all being handled by the same code. Let's just see what happens. Parenthesis expected, line 44. Oh, because I'm trying to do the old, sort of the old cast syntax. Oh, I don't have assert. Thought I defined assert. Didn't I do that? No? All right, let's just make an assert. Assert is a function that goes from a bool to void, and we say if b return, otherwise printf, make sure we don't miss it, red alert, it's a pretty lame assert, but whatever. This is in progress. Okay. All right. So that appeared to work, because check it out. We said, hello, my name is, and then we hit our punting, we got v equals 42, and 42 is the proper value, right? And let's pass in some more things that are hard. Let's say A is a U64 FEDCBA 98765432110, right? B is assigned 16 minus 5150, right? And C is a U8 that's equal to something over 127, right? So 227, right? So A, B, C, new line. All right. Oh, you know what? So the one flaw in what I did is the printf that we're passing to is really dumb, and it's printing it as LLD all the time. So these negative numbers are, or this positive number is going to come out negative, right? So if I print the punting twice, or if I print it here and then I'll print LLX, right? We should be able to see that hex value. Wait, I got to pass V twice. All right, so there we go. That's the hex value, 5150, 227. So that's all working, and that's great. So far, for both ints and strings, actually for everything, we're totally type safe right now. And if we don't understand something, we just print this. And instead of printing this, okay, so here we'll continue, right? And down here, this is a type we don't know or don't yet handle. We're just going to say write string unknown type. All right. So there we go. And we're not getting that right now, but if we pass, I don't know, what's let's just let's pass the pointer to print. Hopefully this doesn't trigger a dependency error. All right, no. So we get an unknown type, right? So now let's get rid of this punting and let's actually print the value. Now, when I printed integers in the original demo, I did something lazy that like does the number and reverses it. And it looks like most people print integers backwards because that's the easy way to do it. And just to have moral superiority, this is not necessarily fast. This is not the recommended way to do it because I'm having fun. I'm going to print the integers forward. How do you do that? Well, like I said, we know now output, well, print U64 of V whoops. So we need to fill this in. We know our number has been promoted to unsigned 64-bit. And what do we do then? What we do is, the way I did it last time was, if you take a number mod 10, that'll give you the least significant digit, and then you divide by 10 to shift it down, right? So you mod 10, divide by 10, mod 10, divide by 10. Actually, you know what? If we print in hex, it's a simpler version of this concept, and we can just make that work, and then we can make the formatting work. Well, let's make the hex version work. Print U64 hex. All right. Here's how we're going to do it. We're going to print it out one digit at a time, and one hex digit is 4 bits, right? You go 0 to 15. So there are 16 4-bit words in a 64-bit number. So we're going to say 4, 0 to 15, and just do some stuff, right? And what we're going to do is we're going to say, mask is a constant that's f 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Is that the right number? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Some languages have ways of like putting commas, or like I think I don't know. There's a couple languages that let you do this in a number, and I may do that because big hex numbers are crazy, but we don't do that yet, so gonna have to suffer with this. Let me put a comment up here. That goes okay. So that tells us which column we're in, right? So this should be the same length because this is 15 or 16 digits, right? 1 to F and 0. So that's the mask, and what we're going to do is we're going to say, I don't know, make some dumb name, W, or yeah, W equals, oh, and I have my horrible bit operators that they're not operators, they're functions right now, right? So I'm going to say bit and V with mask, and I'm going to shift that. I'm going to shift. No, I'm not. What am I going to do? What am I going to do? Yeah. Okay. I'm going to end that with the mask. How am I going to... So the integer version... I would use div and mod. I would divide by the thing, then mod it. Right. So I would say... let's have something else called mod. I don't know. These are both masks, so it's not that great. Anyway. Should I do it? So here's the thing: is it's easier just to do this in a different way because you can just shift the number up. So you know what? Screw it. Rather than doing it analogously to the integer version, I'm just going to do the hex version. I don't know why I decided to do the hex version first, but here we go. So I'm going to and W. So that'll be a number, and then I'm going to say bit shift right W by 60, right? So this is an unsigned bit shift right that'll put zeros in on the left. So once I've done that, I've got a number between 0 and 15, right? And then I'm going to say digit is, should I subscript I'm not going to subscript something. I'm going to say a digit is an int, whatever. And I'm going to say if w is less than 10, then digit equals character 0 plus w. Else, because I don't want to use lookup tables. I don't want a data footprint. I mean, it might be faster. You might benchmark it and find that you'd rather look up in an array that goes from 0 to f or whatever, but digit equals character a plus w minus 10. Right? So if we're at 10, we go a through f, and otherwise here, right? Oh, but we don't want that to be an int. We want it to be a u8. Oh, no, let's make it be an int. And then we'll say the reason why this is going to be is because we're going to do something really goofy. Actually, here's what I say. Oh, what do we do? So eventually we're going to be printing this into a buffer. But for now, we're just going to print it one character at a time. So let's just be as maximally hacky, right? Clean up. Eventually, this should concatenate into a buffer. For now, we are just going to be horrible people. So I'm going to say output is an array of 2 u8s. Output of 0 is casting casting to u8 digit. Output of 1 is 0 and write string output. This is really slow. We're going to write one character at a time. Like I said, we'll clean that up eventually. Okay, I haven't remembered something here. So we're ANDing v by mask, and this is not the fastest way to do this, but we'll say v equals bit shift right of v by 60, right? Let's just do that. Signed versus unsigned. Are my characters unsigned? Oh, because W is a U64. That's interesting. Yeah, let's just do that. Doesn't matter, I don't think. We wanted a string. Oh, right. So we want to cast to a string output. Oh, God. Okay. Okay. Undeclared identifier print U64 because we changed the name to hex. I hope this works. That didn't totally work. So we got our first F from our first number, and then we just failed to get anything else. So what did I do wrong? People on the stream, what did I do wrong? Okay, so W is ANDing, right? So we got that. That W part worked. Oh, not 60. No. In fact, we bit shift left by 4. Goofball. What was I even doing? All right. So there we go. We got our hex number. And then we got minus and another hex number. And then another hex number. So we might want to format these. So for example, this implementation that I just did always prints leading zeros. We might not want leading zeros, right? We probably don't want negative signs if it's hex, right? With hex, the convention is you don't write the sign because it's sort of implicit in the format. You would just write the number. So we're going to want to make all this stuff work. But first, let's have integers. So instead of just print U64 hex now, we'll be able to print decimal. And here's how we're going to do this, because like I said, I want to have fun. Let's go to Wolfram Alpha, right? So we have a 64-bit number, right? Which means the highest value that we can get, because it's unsigned, is 2 to the power of 64 minus 1, right? So in decimal, that is this number, 1.8 something times 10 to the 19. So if I want to start at the beginning of the number and divide by powers of 10, right, then if I divide by 10 to the 19, I get the leading digit. And then I just keep reducing to 10 to the 18, 10 to the 17, 10 to the 16, and walk my way down. So I'm going to do that, and that lets me do it without having intermediate buffers and without writing backwards. And I just want to do it this way. This is all goofy. In the long term, we probably get much more serious about this stuff. But for now, my goal is to be able to experiment with the API, right? So I just want a couple simple things. Okay. So we're gonna say, and again, I don't have a way to put. Okay, I don't have a way to put commas in numbers, so I'm going to say, what am I going to call this? I don't know. Denominator, right? No. Digit, no. I don't know. Divisor. Is it divisor that's on the bottom? No, divisor. I don't know. What I'm going to call it divisor. I don't remember what a divisor is. So divisor is going to be 10 to the 19. So 10 to the 1. Well, we'll specify for clarity that it's a U64. 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay. So we're going to say while divisor digit is v divided by divisor. Divisor gets divided by 10. And v gets modded by divisor, right? Now, well, let's say, yeah. See, down here we call digit the actual ASCII value, so I shouldn't call it the numeric value. Let's call it place. So now I'm going to say digit is char of 0 plus place. And that's about it, right? Let's do the same thing. This really disgusting thing. I think that's it. Maybe I've made a horrible mistake, but I think that's it. That's really simple, right? You don't have to walk backwards. You don't have to break your brain. Let's see what happens. All right, yeah, so we have minus. Let's put some new lines in there so we can actually see our numbers. So we've got A, new line, B, new line, C, print, new line. All right. So that's our big hex number, and hopefully that's correct. Let's actually ask Wolfram Alpha since we're there. In hexadecimal. Yeah, FEDCBA 9876543 blah, 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 right? That's pretty cool. Go Wolfram Alpha. So that's appears to be working. Now let's make it a little more readable. Let's pass in a print leading zeros option. Print leading zeros. Whoops, not in the hex. Well, we'll put it there eventually too, but we'll put it here. Print leading zeros, which is a bool. And we're not going to say what it is yet. And down here, we're going to say false, right? Now, so we're going to say if we're not printing leading zeros, then if we've got all zeros, then continue, right? So now what's all zeros? We're going to start with that being true. All zeros means we've only outputted zeros. Now, if we're printing the number 0, we actually want to print the very last 0. And the very last 0 will be when we're about to exit the loop, so divisor will be 0 at that point, right? Because it'll have been 1, we'll have divided by it, and then it'll have been divided by 10, so it's 0. So we'll say if all zeros, if divisor is gone, then all zeros equals false, or if place all zeros equals false, right? So if either of those conditions, right, place means we divided, this is shorthand just like in C for if place is not equal to 0. I just like writing it like that. Well, all right, let's just do it like that. Okay. So if we are saying print, really if I want to optimize this, I put all this into here because we don't care about all zeros unless we're not printing leading zeros. So now I should say the reason this is a very simple decimal printing routine. It's not the fastest one because if you're printing out small numbers, we're going to be dividing a lot before we start getting to the range of numbers we care about, and we're probably printing small numbers most of the time. But you could do a speed up, like you could check on the input like whether v is small and set this to a much smaller thing if you wanted to. I'm not going to bother because, like I said, I'm working on the API. But let's see what happens there. Hey, look, we got no leading zeros. That's great. So now, now I want to start getting tricky. So we've got a few ways to print integers now, right? We can print hex. We can print decimal. Actually, let's put the leading zeros into hex as well, just so that we have that option. Whoops, I thought I pasted that. Come on, Emacs. Don't fail me. Ah, what? I guess it wipes your mark when you mouse click. I don't even know. Frickin' Emacs. So I'm basically just going to paste the same code in here. If we were being crazy, we'd like factor it all together. Except you don't want to factor stuff together because for speed, you want to factor it apart usually because you're doing something specific. All right, so let's rename W to place because that's what we called it above. Place, 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 place. All right. So now all zeros is false, or true, sorry. Okay. Let's factor this way so it's more readable. And let's divisor. Right, so instead we're going to say if it, right? So here we're iterating a fixed number of times. So if we're printing 0, the last time will be it index, which is our implicit loop counter, is equal to 15. We don't really have an equivalent of a divisor for this version because the math is not exactly analogous. So whatevs. Whoa, okay. It's not it index, it's it because we're iterating over an integer range. Maybe I should make it index valid in that case too. Let's go back to printing hex. In fact, let's print both. Like, I'll print that, and I'll print, what's it called, write string. I'll write a little equals, and then we'll print the decimal. Oh, and I need to say no leading zeros on either. Okay, great. Oh, and for the hex version, so instead of printing both now, because we know they both work, remember we don't want to print the hex version. So we're going to have a variable here called do hex, and for now it's going to be false. And when we get here, we're going to say we only put a minus. What do we do? I'm not sure what will happen if I cast from an S64 to a U64. I think nothing, which is what we want. So you don't want to negate the number if it's hex, right? So let's just say if we're doing hex, we do all this, otherwise we do all that, and we're just going to keep them separate, even though you can condense these if statements a little bit. If we're doing hex, it's just cast to U64. We might support binary eventually or whatever, but for now we're just doing hex and integer. So if it's an integer, we want it drawn in everyday human way, and if it's hex, we just do the U64. Oh, wait. Actually, no. I mean, we want this way out here. So all this complication is going to be inside the else. That's the right way to factor this. And sorry, now I'm confused about all my factoring. If it's signed, what did I do? What did I do? Wow, such a mess. All right. Let's make sure that this is sane. Okay. So if we're doing hex, we just get a U64. No, that's not right. Wait. Is it right? What do we want to do if somebody... I'm going to leave this as undecided. Like, what do we do if somebody passes us a small signed integer and wants to print it as a large hex number? Do we print a small hex number, or do we print the large hex number? It's unclear. I'm just going to do this, and this may not be right, but we've got some things happening, and we can factor it around in order to get the right response. Okay. Anyway, if it's hex, we're going to do that, otherwise that. Now, well, And then I guess we'll put the prints up in this action, right? So that's kind of reasonable. Sort of. Okay. So do hex is false, and there we go, and let's change it to true. And there we go. Okay. Now, we have no minus sign anymore, so that's good. Now, we want to start getting to the versatility bit of this. So I want to be able to, here I've got this do hex specified here, and I've got, let's do leading zeros. Let's turn it back to true for a bit. So right now this is hard-coded, and I want to be able to not hard-code these, right? I want to be able to do them in a type-safe and versatile way. So how do we do that? Well, here's my idea, right? So now we've got our leading zeros back, and we're in hex. And we can go back to false and have leading zeros. Okay, that's all great. Now, how do we pass formatting info? So my idea of how to do that is like this. I can make something called format int, right? This is going to be a struct, and it's going to have these values in it, right? It's going to have do hex by default is going to be false, and do leading zeros by default is going to be false, I guess. Right. So that's a struct, right? And now, this isn't a language where we have constructors yet, so we're not going to say like format int of whatever like you would in C++. But I'm going to make a helper function for now that says, I don't know, I'll start it with a lowercase letter, right? Format int. And I'm going to say that's a function where we take an integer. Question is, what type should the integer be? Well, this is interesting. We'll make it an any, right? We make it an any argument. Integer value is any, right? Because we want to be able to pass all different kinds of integers in. So we're going to make a helper function called format int that takes integer value, that's an any, do hex, that's, and this is going to be cool because we're going to be able to use our optional arguments and our default arguments and all that stuff. We're going to say do hex is false and do leading zeros false, and this returns a format int, and we're just going to do the obvious thing. We're just going to fill it in, right? Result is a format int, and result.integer value equals integer value. This is a little tedious, and you might imagine wanting object-orientedness here, but I don't really know if that's worth it. It's to be seen. Result.do hex equals do hex. Result.do leading zeros equals do leading zeros. Okay, let's make sure that compiles. For all I know, I broke returning large structs, in which case we're in for goodness. Okay, at least compiled. So now here's what I want to be able to do. Let's make a number. Let's comment out all this stuff. I want to make a number n. That's 100. And I'm going to say print the number is n period new line. Okay, so I'm going to do that a few times. The second time, though, I want to say format int n comma do hex equals true. Is it called do leading zeros? Yeah. And then we'll say do leading zeros equals true, right? So we can sort of make a little type here in the middle where we get arbitrarily complicated about what our formatting is, right? Like we could say, oh, left justify, or print at most 7 leading zeros, or whatever. We could do all kinds of things in this format int. And yeah, you could say print binary or whatever. So now this should actually work right now, in that the code should run. The first one should work because it's just going to our old thing. But these two, this function doesn't know what a format int type is. It's going to be like, what the hell is that? So those should trigger this unknown type. But my theory is, if I didn't make a syntax error, that this should actually work. Well, expression is not an L value. What did I do? This is probably a compiler problem. It's probably complaining about trying to convert this to an any. So let's find out. Let me put this into an intermediate value. See, like when you try to make something into an any, it takes an L value of it, and for some reason that failed in this case, I think, if I'm correct about the problem. So my approach is going to be to try and work around it, and then if I can't work around it, then I'll go solve the compiler bug, but I'd rather not solve the compiler bug. Okay, there we go. So that worked. So making it into something that has an L value explicitly worked, and so I'm just going to have to go later and make it work when you put it in line. Right. Okay, so here we do that, and then I can say do leading zeros is true, and do that. So step by step, we're getting better. So we should print 3 different things, right? So this should be 100 in decimal. Eventually, when we handle this, this will be 100 in hex with no leading zeros. Then eventually, this will be 100 in decimal with a ton of leading zeros, right? But for now, it's still not going to totally redecoration to format because, yeah. Okay, so cool. So now we just have to handle this format struct. And how am I going to do that? Well, I'm going to first factor all of this integer stuff out into print integer from any, right? With, and I want a default format struct because I'm going to make something that takes a format. So I'm going to say default is some format int, and that's just going to fill that out with these default values that are on the struct. I could also call this, but whatever. I'm going to print integer from any with default. Let's put the format second and the integer first. The integer was, well, we want the any, and the any is it, right? So that's going to factor out all this stuff. So we print integer from any and continue. And that makes this would eventually grow pretty big anyway, because this is going to handle all these cases. So we might as well factor this out. So print integer from any value is an any, and format is a format int, right? Now, thank you, whoever made this. I forget the dude's name who made this Emacs mode for me. He should get official credit because it's so good to just be able to indent all that. So thank you, maker of the Emacs mode, whose name I don't remember right now. I'm such a bad for not remembering. Okay. we've got, so instead of do hex is false and do leading zeros is false, let's get rid of that, can that stuff. We'll say if format do hex, format.do leading zeros, and format.do leading zeros. So I'm going to assert value dot type is equal to type info tag dot integer, right? Make sure nobody calls us with something crazy. Wait, why was that? Right, we want the extra type. Value.type is a type info, and .type is the tag, so that could be a little easier to remember on it, obviously. All right, so we cast it to integer, and then we do all this stuff that we did before. And so now we've only refactored, so if I didn't mess it up, it should just do exactly what it did. Well, I missed something. Oh, I keep doing this. Undeclared identifier it, because it used to be called it. Value.type. Oh, and then value.value pointer. Instead of saying value.value pointer, I'm going to call this any instead of value. All right. Okay, so cool. So we're still printing our 100, but now we've got these unknown types, right? So now we're going to handle a format int. So if t is equal to, is it called struct? Yes. If t is equal to struct, for now we're just going to write string struct and continue. So let's make sure that that works. Okay, cool. So we got two structs. So it knows that these are a struct. Now, what kind of struct, you ask? Well, if it's a format int, if t dot t.type is equal to type info format int, I think that'll work. I change the semantics of type info sometimes, so this might not be the right thing to type. We might have to do something hacky, but hopefully not. So if it's equal to that, we'll write format int, otherwise that. Didn't like it. Attempt to dereference a non-namespace type. T, oh, it's not T. We want it dot type. Hey, look, check it out. Format int, format int. Now, let's get rid of this print got %d arguments. That's just making noise. Okay, so we got 100, format int, right? And now let's actually do the job that we came to do. So we're going to call print integer from any with the any that we got, which is it dot value pointer, right? No, what was it called? It dot integer value, right? That's where in our constructor for format int, that's where we stuff the integer value, right? So we're going to pass it dot integer value And let's dereference the format explicitly. We'll say format is star cast to pointer to format int it.value pointer. Remember, it is one of these arguments, and it's got a type and a value pointer. And we cast the value pointer to string up here, and we cast it here to a pointer to a format int, right? So, and then we have dereferenced that pointer to get the format, and we're passing it by value to print integer from any. And then we'll continue. Integer value is not a field to struct any. I said the wrong thing. Format.integer value, not it.integer value. Hey, successful demo, writing things from scratch. So that's pretty cool. We now have a type-safe print function where you can twiddle around with the format as you want, and you'll be able to do it inline. Maybe we'll work on that a little bit. You'll be able to do it in the middle of the string, and eventually we might do string interpolation or something. But for now, it's pretty cool, I think, that you saw every single building block of how I'm doing this and how it leverages the language features that we've implemented so far. So I'm going to take a short break to refill my water and stuff, and I'll be back to take questions on anything we did here in just a minute. So, do people have questions about what happened? What the hell is going on? Okay, wait. I got something wrong. I hope somebody caught this. Hold on. Because the things that we printed out don't match what we just said. Because we said do hex in the second one, and I guess that is hex. But we didn't say do hex in the third one. Oh, no, never mind. That's right. Duh. I'm used to looking at a long string of digits and thinking of it as hex, but that's decimal with leading zeros. So this is all correct. We're all good. What kind of dances do I do at clubs, and will we ever see footage? You may someday, but it is off topic for a compiler programming stream. But we are only taking on-topic questions right now. Are there any on-topic questions? while I'm waiting for questions, I'm going to change this to an enum. So I'm going to say enum format int base. You know, I usually don't do camel case. I usually do underscores, but for some reason I felt the need to do camel case right now. I don't know. Decimal. I hope that's right. Binary. I don't like octal. We're not going to do octal because octal is for bad people. Let's say base. All right. This way of formatting could get pretty verbose. Am I planning on abbreviating it? Maybe. You can put all sorts of front ends in front of this to abbreviate it. Like, you know, you could make a function that takes, you know, format int of n and then, or let's pretend it's a floating point number, right? Format float, because those tend to have a lot of weird options. You could do a C-style version of like this, right? Like 3 digits before the decimal point and 5 after, right? And it doesn't matter because you're filling out the same struct. So you can have a different API to fill out this struct and it's fine, right? And that's my goal, is to make a core system that you can use however you want. Someone's saying, is checking the type info in your print function really the best way to do polymorphism here? I don't know. This is not really polymorphism. This is just switching on a runtime type. I mean, you can call that polymorphism, but it's not really, right? This is just runtime type checking of things. Will there be more format structs for string widths and stuff? Sure, you can make whatever format structs you want. That's the whole point. If the integer value is included in the format int, why do I pass it into the printing function separately? It's a good point. Actually, let me fix the base thing, and then we'll get rid of that extra argument. Okay, so if format.base is equal to, let's do using here again. Using like if this were in a module somewhere, I probably would use all of these globally within the module, but they're not yet. So that's integer. So if format.base is equal to hexadecimal, else we'll assume it's decimal for now. And then I don't like camel case, man. I don't find it that readable. I wanted to try it because, you know, people like camel case sometimes. Format, where am I? Do hex, so base equals so I don't need that up here. I need that down here. I don't know. I feel like I missed some things, but let's see what happens. Oh, ha ha ha. My own compiler is smart-assing me. Argument name base is not found in the procedure being called. That's right, because I didn't change that. Base. Dot base is base. So since this is basically just a wrapper, you could imagine some way of saying I'm just calling a function that constructs all these members with optional values. Like this if you end up doing this a lot, this entire function is useless boilerplate. So rather than having to define a constructor like C++, I would rather do something where you say, I'm calling a function that generates this. We'll talk sometime about what that might be, but first I just want to start doing this and see if I feel the need for that. Oh, this is a compiler bug. Oh no. Oh no, what? This is terrible. This might be a showstopper. This is like, this means there's a dependency problem. This is terrible. Let me try this up here. It's not that much of a showstopper. I just will have to do something ugly. But whenever there's like a dependency problem, it can be not that fun to watch me debug it. Oh. Maybe I didn't make this work in global scope anymore. All right, so here's what we're going to do. We're not going to using that. We're just going to say, for now, decimal is 0. Hexadecimal is 1. This is weird. I've got that point where you look at a word and it looks like it's spelled wrong. Binary to... We're just going to do that for now to work around this compiler bug. And get rid of that. Get rid of that. And get rid of that. So this should work. Hopefully. Yeah. Okay, so we're back to where we were. And let's write binary really fast. Because why not? Print U64 hex. Binary. It's gonna be like hex where we just get it. Oh, we were gonna get rid of the. Let's get rid of the argument, right? And really, like, I feel like eventually we should just be passing the format struct all the way down. But we don't. Yeah. Anyway, so we're just going to say auto, or not auto, this is not C++, any format.integer value. So we're just not going to pass it as a parameter, but just to be consistent, it's not really that big of a change. Too many arguments. Right, so that simplifies that, which is nice. Okay, so that still works. And, okay, so I was going to do this. So I'm just going to copy the hex. And I'm just going to do the ugliest possible thing. I've just copied and pasted the hex for now. The mask is 1 bit and 63. Is that right? Shifting right by 63. Yeah. Bit shift left by 1. Oh my god, this is so disgusting. Whoops. I should actually test printing 0, because that's sort of like the singularity case in all these. So plate digit U64 is character of 0 plus place. That's so lame. All right. The most inefficient binary. I'm sure people have written a more inefficient binary number printer than that. Who am I? Anything in JavaScript is worse. Okay, so let's use it. We're going to say format is format int n. Base is binary. Do leading zeros is false. Right. All right. Hopefully that's right. 1, 2, 4 plus 32 plus 64, 96, 100. Yay! So that's cool. We can do all these things. It's very nice. It's very nice. And we've written 277 lines so far today, which is a mere 27.7 times the average daily output of a programmer across all industries. Not really a fair comparison because it's not shipping code, but it also hasn't been a day. It's been me working late at night for a couple hours. And checking for more questions. Can I print the value of a pointer in hex right now? Yeah, I mean, we can do that. If there's interest in adding that, we can do that pretty fast. Some others mentioned this. Shouldn't you be printing OX64 instead of 64? Maybe. That's like a formatting option, right? If you're formatting in hex, you could print the leading OX or not. It depends on what your priority is and how you're organizing the library. If your priority is to write things out so that they can be parsed unambiguously, then maybe you always want the OX, right? It doesn't really matter. Right now we're working on the principle and not the details. Do you think there's a value in having a print function that is analogous to C in terms of arguments, %d, %f? No. The %d and %f in C are what makes it not type safe. So I don't like that. I don't necessarily have a problem with putting information in the string about where to put stuff. So, for example, for localization, this is actually not that convenient of a thing. It's more convenient to say if you had two numbers n1 and n2, right? You might say, I don't know, print I like first number, right? She likes this number, right? Where these numbers in the brackets actually refer to which argument index, right? And the reason why that's good sometimes is that in some other language, it might be phrased more like, I like 1, therefore she likes 2. Might be phrased, she likes 2 because I like 1 in another language. Like, right? You might have this reversal of terms, and it's hard in code. You don't want to have a bunch of if statements in code about what language it is. You want to factor this string off into some string database that changes for each language, but you want to pass the same arguments, right? So you might have reasons to do that, but you don't want, you especially in this case where you're swapping them around, don't want them to say %f, %d or whatever, because then you'll just crash sometimes, right? So we might eventually work our way towards an API that does this, right? But we're not going to do the %f thing. That's not cool. Someone can do it. Like, you're free to do that on top of what I'm doing here, for example, but I don't think it's a good way to do it. Looking for more questions. Looking for questions. Thank you for the braces syntax. Well, I haven't implemented it. I'm just talking about it. Okay, let's do pointers really fast. Print here is a pointer, and let's make it the pointer to n, right? And we'll have pointers. This is going to be interesting. I'm going to recurse. I'm going to have an unformatted pointer. We can make a format struct for pointers and things, but we at least want to recognize an unformatted pointer. So we're going to say if our type is a pointer, I'm actually going to print it as an integer that's unsigned 64-bit value. I'm going to say any. Well, first, I'm going to do this in a few steps so that it's unambiguous, right? I'm going to say U64 value, right, is casting to U64. Do I support casting pointer to U64 right now? I don't actually know. Let's find out. It.value pointer. Actually, no, because it.value pointer is a pointer to the pointer. We know that pointers are the size of U64. Well, how do we want to do this? Let's try this. Star cast pointer to U64, it.value pointer. Is a little bit dangerous, right? This assumes we are running in 64-bit. We could clean that up later, maybe. Just tired, so the first thing that enters into my brain is what's coming out. So that's going to be a cast to U64, and that's a U64 value. And now we're going to say, we'll put it down here. We've got a default format int, and default.integer value equals U64 val. And that'll actually cast that up to any. And then we're going to print that as an integer. Actually, I said we were going to recurse, but we're not. We're just going to do that. Let's see what happens. Okay. Here's a pointer. I forgot to do a new line. So there, we implemented printing pointers. I did it with no leading zeros by default, but you could make a formatted pointer struct and all that. What about 0:s or something? Yeah, I mean, if you want to do... Oh, no. For formatting options. Yeah, I mean, it's up in the air. Like, basically what I want to do right now is make a relatively straightforward way of doing arbitrary formatting options that's type safe, right? Now, once I've got this, you could imagine, if you want to encode this into a string, you could imagine a multi-step process where you call something that looks to see what's in the string and like breaks it apart and does this formatting and reconcatenates it, right? Now, you might not want to do that because that might be slower or something, right? If you want to be fast, maybe you want to do it this way. It's unclear, right? So what I'm trying to do is sort of the lower level version of printing, and then if you want to do a higher level thing on top of it where you can encode the formatting in the string, then that's totally cool. And my job is to design this part of the API so that you can hook into that very easily with whatever you want to use, right? If somebody feels like they have to write their own version of Printf, then this is kind of failed, right? So you don't want that. You want people to be able to hook onto this and be happy. Now, the next part of that, like I said, right now, this is all just printing to the console in a very inefficient way. Eventually, you want this just to go to buffers, right? Doing that well, maybe I'll do that next stream, and doing that well is part of what makes this reusable. And I haven't thought about exactly how I'm going to do it yet. I'm just going to start doing it. What about the number of leading zeros or even alignments? Yeah, you can put all that in the format options, I think. It just, you start making the job of this code lower down a little more involved, because if they have to think about how to justify the numbers and stuff, that's totally fine. It's just today I wanted to just get the very basics in there. But anything about formatting that you feel like specifying, you can just jam in here, right? And then this function will know how to handle them. So there you go. How do I plan to handle structs? Okay, I can refer you to a previous demo about how to handle structs because I basically did it. Let me run it, and then I'll show you the source code. That's not the right window. So if I run, hopefully it still runs, tests, demo type info. Huh. I got another expression is not an L value. That's so weird. Let me see. Let me just go see what's going on. Right. I'm gonna. This is probably like a 2-second bug to fix, but I'm just gonna put it on my to-do list. All right. So this type info demo. There's a video on YouTube called Runtime Type Information in the stream for this stuff, where I print these things. And oh, actually, this isn't even the one that or is it the demo that I wanted? Anyway, so in this demo, I'm printing out all the types. First of all the types in the whole program, which includes all the struct types, right? Oh yeah, down here. So here, I serialize these fonts. These fonts are like just structs, and I just print out the field name and the value, right? Let me go. It's been a while, but so this font settings A is just some font settings struct, and this serialize function takes an any, and if it's a struct, it just prints out all the members, right? So for any default struct, if people haven't installed some handler for that struct, you can just do something like this, where I basically would cut and paste this code almost verbatim, where you then go and print this stuff, right? Now, the question is, how do you nimbly allow people to install handlers? Maybe you just give them a format handler that has a callback function pointer, right? But there might be a better way to do it than that even. So, I want to play with that idea, but the infrastructure is already in the language for handling that. And if I weren't totally tired and didn't want to go home, I could just go and do that now. But it's in this previous demo that you can watch on YouTube where I explain it in much greater detail. What do I think about implementing slices? This language already has slices. I think a slice is just an array of where the length is a variable on the array, and we already do that. So we don't have syntactically convenient slicing operators right now. Like you can't say array sub 0 to 5 or something to generate a slice, but not sure we really want that. I have to see. I'm going to copy this biff.jai thing is my scratch file that I never check in. So I'm going to copy test biff.jai to tests print, right? Does this shell do this? Yes. Eventually all that stuff's going to go in basic or something. Do I like green threads? I don't know what a green thread is. Our threads are going to be probably not very restricted. It's not going to be something like Go where you could only talk down a channel or something, because that's kind of useless for high-end game development. But we're going to have things that we do that make threads much more robust and less error prone than they are in C++ currently. And what those are we'll show off later. It's a little off the subject for tonight, though. I think that may be the end of the stream. I think. Green threads are non-native threads, like threads which are multiplexed on top of OS threads. I think you want good control for OS threads before you start monkeying around with something like that. So, like basic threads first, then we talk about that. Something off topic, but why did I choose to implement the bytecode in a register-based machine instead of a stack-based machine? Because I think stack-based machines are slow and hard to understand. I used to program in a variant of Forth, and it's terrible. Sorry, Forth people. And I didn't want to condemn myself to that. And a register-based machine is much closer to SSA, which you're going to want for back-end optimizations, and it's much closer to what the chip actually does. And I don't see a benefit to a stack machine. I don't understand why I would implement one. Maybe there's a good reason, but I don't know what it is. Don't ask me about editors, jeez. Why Emacs over Vim? You could say J. You could pronounce this J if you want. It's got both pronunciations. All right, folks. Thank you for hanging out. I am going to go home and go to sleep. It's been fun. I don't know if I'll stream tomorrow. If I do, I may go in and do this buffer stuff. Like before work in the morning, I might try and fix that L value error that's annoying. And then maybe we'll do buffers in the afternoon. Oh, maybe I'll try to fix that dependency error that came up. Oh man, I don't want to think about that. What a headache. What a headache. Good night. I'm going to post this on YouTube tomorrow if you missed any of it, but it'll probably take toward the end of the day because Twitch is slow and YouTube is slow, and it's been a couple hours. Good night.